So I don't know if any of you were at Farm Smart last year and had a chance to listen to Scott's talk about where his vision for machinery is going vis-a-vis the implications of that relationship between machinery and the soil and its carrying capacity. So he's going to address that just for a few minutes here, and then Andrew and Scott will join. Andrew and John will join him on stage, and we'll do a Q&A until lunch. Okay, so Scott.
Thank you, Ian. What I want to do next is that we kind of got into doing compaction work in part because I came back or had the opportunity to come back to Ohio State. But the other thing is we got pretty involved in doing some modeling of future equipment systems in agriculture. And we were trying to look at what was going to drive the use or deployment of certain technologies. And so I want to kind of remind people what I started out with, this increasing size of tractors. I go to manufacturers and I say, why do you guys build such big tractors? And their response is, farmers buy them, okay? So then I get in a room full of people like you and I say, hey, why are you guys buying such big tractors? Are you ladies and gentlemen buying such big tractors? And the response I get is, well, the manufacturers build them. Okay? So I don't really see anything stopping this circle towards this increasing trend towards bigger and bigger equipment in some respects. And just every time I think I've seen about the biggest piece of equipment, I go to a meeting and I find a bigger piece of equipment in some respects. And so I'm kind of thinking, why is that trend going in that direction? Well, I think really there's a couple things driving it. First of all of our equipment has a human operator on it, okay? And as much as anything, that person's really kind of in control of your operation. They're making a lot of the decisions that affect your bottom line. Now, I think the other thing is, and I notice this increasingly more and more, it's all about planting capacity. It's all about trying to get the crop in the ground at kind of the optimal time of year. And we know with some of the weather events, it can be a challenge at times. But what I would say as much as anything in the state of Ohio is most of our farmers are in a position where they can largely plant their corn in a 10-day window, okay? Now, I'd argue some of the farmers we have, because, crop prices are pretty good, 2008 through about 2012, there's probably some of our farmers that can probably plant that crop in about 8 days, okay? But it's because they've ramped up in terms of equipment, and there's a lot of things going on that kind of affect decisions, purchase decisions, tax benefits, and things of that, especially when you're in years where it's reasonably profitable. But I keep wondering to myself, what's going to change that trend about increasingly larger and larger equipment? As much as anything, if I look at tracks on tractors, really what it allows us to do is go to higher horsepower and still keep that a reasonably narrow piece of equipment, okay? And I'm reminded of, in Europe, they have a 3-meter and a 3.5-meter transport width limitation. But most of their high horsepower tractors now, the really high horse ones, now there's still a lot of wheeled tractors there, but when you saw that Fendt tractor, when you look across the back of the tractor, there's only so much tire you can put under it and still meet the 3-meter transport limitations. The tractors really allow the Europeans to go to higher horsepowers in some respects. And so what I keep thinking about is, what are the things that are going to shape the trends of future pieces of farm equipment? And one of the things I think a lot of people aren't thinking about necessarily is compaction. The other thing is, in the state of Wisconsin, this law was passed recently. They really haven't addressed the width of farm equipment, but they started addressing the overall gross vehicle weight. And right now, operating in state routes in the state of Wisconsin, you're limited to 92,000 pounds gross vehicle weight. That's for everything that's hitched together when you go down the road. And by the way, if you have bulk fill tanks and things like that, they cannot be over 20% of capacity in terms of what's in those tanks when you move that equipment on the road. The other thing is they're starting to pass some laws on the overall length of the equipment. And so, again, when I keep looking at the equipment going to increasingly larger and larger sizes, the question is, what is the physical limitation in terms of public or transport on public thoroughfares, okay? And I'll be the first person to admit that I don't understand everything going on around the world. And you know, I know in parts of Canada you have fair amounts of latitude. I know in other regions it may be a little bit more restrictive in some respects. And so again, I respect that a little bit, but I think increasingly the public, we've been very fortunate in the U.S. in that for the most part they put up with farmers moving equipment on the public thoroughfares. But again, I don't think it's a given that we're going to continue to enjoy that for a long duration. Another thing I want to talk about, the modern agricultural tractor. And if you've ever heard me talk before, companies manufacture great equipment, okay? And I think most of the tractors coming out today will have a life of 20,000 hours, okay? You put that on a farm in the Midwest in the Corn Belt in the U.S., a farmer's going to use it 500 hours a year. Well, let's do the math. 20,000 divided by 500, that tractor's going to be on a farm for 40 years, okay? Man, that's a pretty fantastic piece of equipment. But then I get thinking about how technology is going to change the ability of that tractor to complete or perform its function as agriculture continues to develop. The other thing I wonder about is how long are the manufacturers going to support electronics on that equipment? I'm not worried about the electronics being supported, but what we know is the manufacturers will probably limit the length of time that they actively support it. There'll be aftermarket companies that continue to support it, but right now, 14 years is the number that I keep hearing. So you got a tractor that has 3 times the life of what they're going to support the electronics on in some respects. Now, I want to contrast, if you will, the agricultural tractor with an iPhone, okay? You realize we've had smartphones now for about 11 years. I know that BlackBerry is just down the road here, so I respect the role that they've played as well. And I only use the iPhone for one reason is because I understand it a little bit better than I do some other devices. But how often they come out with a new iPhone? About every year? Yeah. And what I love asking farmers that use iPhones is, what model of iPhone do you have? I was at an audience, and this hadn't been too long ago, and I finally got one farmer in the room to admit they still had an iPhone 3 that they were using, okay? But by and large, most of us buy a new smartphone about how often? I don't know about most of you, but I usually get a new one about every 2 years, and generally it's when my contract runs out or I paid for my last one, okay? Why do I get a new iPhone? Well, I'm not using iPhones now, I'm using Androids, but why do I get a new smartphone every couple of years? Well, largely because the new technology replaces the old technology, okay? So what I continue to ask people is, think about this in terms of equipment that's becoming more technologically advanced and this mechanical life. And what I'm suggesting is we're going to have to get to a point where tractor life and technical obsolescence coincide, okay? We buy new smartphones not because the previous one quit working, but because we like the features on the new ones, okay? Higher resolution camera, maybe it's gone to 4G or 5G depending upon where you're at. But technology marches on and we like those new products because there's new functionality. So what I'm suggesting is we're going to get to a point where we begin manufacturing equipment where mechanical life and technical obsolescence coincide. I'm thinking we're going to buy new tractors about every 7 years. It's going to coincide with 7 cropping seasons. Wow, that's a game changer, isn't it? I'm also paying attention to how industry is evolving. Anybody heard the term dark factories? You know, in the United States, we had that downturn in the economy in 2008, and we've had a recovery, but it's been a jobless recovery. Why is that? Well, a lot of our manufacturers adopted a lot more automation. So they're producing more goods and products, if you will, with fewer humans in some respects. Begin talking a lot now about dark factories. These are factories that have no lights because they have no people in them. Okay? So technology marches on. I like this map right here, especially the one on the left-hand side. Those are internet-connected devices. There's a projection that we could have about 20 billion of those by about 2020. 20 billion internet-connected devices for about 7 billion people. And my guess is there's a lot of people on Earth that don't have the first internet-connected device. I have a smartphone, I have a tablet, I have a laptop, I have 3 internet-connected devices. Andrew has about 7 or 8, I think. It's got a nice check on him all the time. But the bottom line is we're seeing agriculture connected to the internet. And I know John's going to have some conversations, I guess, tomorrow regarding that. Then I look at this thing about automation, okay? We got Mercedes-Benz automating over-the-road trucks. We got Google, the Google car, okay? It's Uber now has the Uber car. I mean, where does it end? By the way, there's a company that Case IH has been working with, Autonomous Solutions Incorporated out of Utah, that's automated 200 pieces of mining equipment for Rio Tinto, which is a rather large mining company. So in some of these mines where they're moving massive amounts of earth anymore, you go into those mines and there's no human operators in that equipment. What's going to happen in agriculture and what's going to drive that? We saw this at the Farm Progress Show, videotapes, and by the way, those are there's a Magnum and a New Holland, I can't remember which New Holland tractor it was, T9 or T8, but anyways, those were operated in Kentucky, and you'll notice, well, the one tractor doesn't even have a cab, the other one has a cab but no operator, but the technology's there. I used to talk about automation of farm equipment. People look at me like I was nuts. Well, this is today. And so what's really going to happen and what's going to drive a lot of this? If you watch what's going on with data, logistics and agriculture is becoming an increasing opportunity for a lot of companies that never envisioned they'd be directly involved in agriculture. When you look at the value of seed and some of the agricultural chemicals and the need to make decisions on a timely basis, maybe companies like FedEx are going to be supplying inputs to the field. And think about that in the future in some respects. There's a lot of people looking at agriculture much differently than they ever have before. I put this scenario together, and I don't know whether you're going to like it, but I think we go back to 50 or 60 horse tractors without operators. Okay? And the reason why I think that happens is because of soil compaction. I think the price we're paying right now for large equipment is substantial and significant. I think because of the timeliness of operations, we accept it. But to another and certain level, I'm not certain that we know the true level of problems that are being created in accordance with soil compaction. I have some rather well-defined reasons why I think we're going to small autonomous equipment. Some of it could be to be more timely in some respects. And really what I'm talking about is 10-foot wide or 3-meter wide equipment that you can easily move on public thoroughfares. In fact, I make the argument I can load up 4 or 5 of these tractors and reposition them anywhere in the Corn Belt within 24 hours. And so think about how this technology might unfold. Liability is going to require humans to remain on big machines. I don't think there's any question about that. Low-power vehicles are going to minimize that liability. You know, do I have to worry about somebody hacking my tractor, my 60-horse tractor in the middle of a cornfield in Lincoln or outside of Lincoln, Nebraska? Or do I need to worry about somebody that's going to hack my Uber car on the streets of San Francisco? Okay? One of those, I think, is a little bit more appealing to people that might have nefarious interest at heart in some respects. I think the alleviation of soil compaction will likely drive the adoption of autonomous equipment. And I don't think a lot of people are thinking that way. We can talk about labor availability in agriculture, and certainly that is a factor, but when you look at what we might be able to gain in terms of productivity, it dwarfs the gains to be made by replacing humans. In fact, I think it actually creates more jobs for humans in rural parts of our countries. Obsolescence and mechanical life are going to coincide. I think we begin going to a 5 to 7 year cycle in terms of replacing equipment. 5,000-hour life of tractors. I think we go back to spark ignition engines. Right now, after treatment on diesel engines, I'm talking about diesel exhaust fluid or diesel emissions fluid, and also diesel particulate filters is rising to the level of the cost of the diesel engine over the life of the piece of equipment. After treatment is a significant cost in terms of diesel engine technology. I think we go back to spark ignition engines. The other thing is the tractors to get small enough, we use enough symmetry, we can go back to parts inventory in a bed of a pickup truck. And so think about servicing this equipment that's in the field in some respects. Will business models change? Certainly, okay? And one of the things that's going to drive the change to different business models is going to be this constant replacement of technology and new capabilities, okay? My guess is there's going to be some farmers that get tired of owning that new technology. They go to a point where they're leasing it perhaps, or they go to a point where they're contracting for some of that technology. So think about what might be ahead in some respects. I'm going to stop there, but again, the one thing I want to leave you with, there's going to be a lot of things that drive adoption of various things in agriculture, but it may be some things coming from areas that we haven't necessarily thought about before either. So with that, John, do you want to get us started on a little Q&A here? Andrew, you coming up? What we'd like to do now is shift to a phase where we let you ask us some questions. And just in case some of you aren't too vocal, I think John has a couple starters for us here. So with that, John?
Well, Scott, this comes from Max. We were talking about this test. Oh, I got to be on stage? Oh, all right. One thing I don't think you closed the loop on the discussion. Let's go back to tractive efficiency, tire pressure, and there seems to be a little bit of optimization that would be required, meaning if I'm dropping the pressure all the way down using the new IF tires or whatever it might be, what does that do to my tractive efficiency?
When you drop that pressure in the tires, you're getting a bigger footprint. It actually improves your tractive efficiency, okay? So IF tires are a very good thing when you look at tractive efficiency. They're also good in terms of reducing that contact pressure. So you're getting benefit out of both of those. Again, I caution people when you're dropping that air pressure in the tire, make certain you understand the loads on it and you're not violating the warranty.
So, but there's a difference between floating and traction here. It gets us in this.
You can talk about a difference between flotation and traction in some respects, but in this case, both of them coincide to produce a positive benefit here. So you're getting improved tractive efficiency. There have been some very good studies that have been done by Firestone on this. Improved tractive efficiency with the lower inflation pressures and the IF tires, and also improved flotation.
And not to leave Andrew out, but Andrew, I think one of the questions I think a lot of people probably have is, and I'm going to put this on you because you're out doing the, when do we do our tillage, and what kind of tillage tool do we need to start utilizing if we start to see? Because I know we've mentioned this whole thing, or at least in the state of Ohio, we'll go back to this whole drainage issue. We had drain tiles in for 30 or 40 years. We've come back and split the middles of those, whether that's 30, 40, maybe in some cases 20 feet. But in those cases where we have deep compaction, I guess tillage timing and tools that you would just kind of throw out on the table for people to consider.
Yeah. So we have several different tillage tools. We have inline rippers, we have disc rippers, we have vertical tillage tools, and the albeit the moldboard plow, we don't have any of those, but one of the solutions that we came up with, and we've talked about this, is we have nutrient stratification. So we have both compaction and nutrient stratification, right? Two issues. But looking at moldboard plowing, not only to alleviate compaction, but also take care of that nutrient stratification issue. One thing that we're really heavily looking at is the disc ripper. So we talked about some of those issues that you have with the vertical tillage tool and actually going out when it's too wet. John had a picture up earlier that even the cultivator, if you go out and you have your tractor ballasted incorrectly or if it's too wet, even then you have compaction loss or yield loss. So
Andrew Ian's over here just about ready to have a coronary, okay? He's kind of a bit of fancier of no-till. So as you're addressing some of these things, what are the no-till farmers going to do? And I'll let you finish up.
yeah, so looking at least on our farm, and this is coming from a farmer aspect. On our farm in Northwest Ohio, we really tried to adopt no-till. So I'll go into this. And the one thing that we noticed, we started to lose significant yield after about 3 to 4 years. So we started looking at inline rippers. You want to try and keep the residue on top and not incorporate that in. Obviously, in your Midwestern states, you have a lot of the higher corn yield, so you have to do something with the fodder. The disc rippers are the best thing to do. But obviously, you start looking at the imagery and you start looking at machinery data. How can we start to marry those together where on hillsides you may want to bury no topsoil or any of the fodder, where in the rich bottom ground or in the flat areas you want to bury 50% of it. So now we're starting to look at prescription tillage. So this is sort of a happy medium where you're going to do tillage in the areas that need it and the areas that you don't. So you can start looking at where your grain cart went in the field, you till in those areas, and then you don't till in the areas that doesn't need it. So not only are you preserving that organic matter, you're also saving fuel and time, and also wear on the equipment as well.
So Ian, I think we've got questions from the crowd. I know we got a microphone out here. Do we got others that we can pass around?
Unfortunately, only the one microphone, so you've got to come line up behind Ted. And questions so that more people can get through, because we have questions coming from the WebEx as well.
A question, if you looked at the idea that the trend has been to earlier planting, which is supposed to result in higher yields, but usually going most of the time on soils when they're perhaps a little bit wetter. Any correlation there in terms of compaction? Number two is heavier equipment means wider equipment, fewer trips over the field. How does that compare with lighter, smaller equipment with more trips over the field?
So two questions.
Yeah, two questions there, and we'll kind of take the first one, well, the last one first, I guess, in terms of, I know that we have wider equipment in some respects, but you still need tires to support that equipment. We're going to have wing wheels on planters. We're going to have, obviously, the central fill portion of the planter, if that's the type of planter we're having. I'm not saying that you're not having less trafficked area, but again, I think you have to keep things in perspective and look at your equipment complement. Obviously, we have spray booms now 120 feet, and that's definitely changed that. So we might make the argument that a sprayer, because you have such a wide spray width, the trade-off between getting in and applying, let's say, a fungicide and going through a wet field, okay, you might be doing a little bit of surface compaction. You may be taking a yield hit there, but on the other hand, applying the fungicide may be balancing that out in some respects. And so again, I think it kind of boils down to the operation and the total complement of equipment. And again, I'll also say we have a person coming up a little bit later this afternoon talking about controlled traffic. I think it'll shed some light on that as well. You want to handle the first question, Andrew? Can't remember. John, do you remember the first question?
Ted, where you at? The first part of that?
The first part of that question. Yeah. What was the first part of that question
Sorry.
again?
Earlier planting.
Earlier planting.
With wet.
Yeah.
Got it.
And I had a thought on that. I guess one of the things that I would look at in terms of, I understand people are going to want to get in a plant earlier, and every year is a little bit different in some respects. But I'd say when you start moving a lot of soil when you're going into the field, one of the things that's wonderful about planters in some respects is, the seed boots or whatever will plug up when you're really too wet in some respects. We also have that sidewall compaction issue when we're in wetter soils, and the question is whether we can close those. Sometimes that kind of mitigates itself a little bit in terms of you're just not going to go plant because you can't close that furrow, and you're getting smearing that sidewall in some respects. And so some of that's kind of a self-correcting problem. But again, on the trafficking side, as long as you're not making those deep depressions in the soil and you're still okay in terms of opening and closing the furrow, I'm not quite as concerned there. A lot of what Andrew and the rest of us have been talking about are really the high gross vehicle weight loads. Certainly surface compaction is an issue for planting, but again, I'm not quite as concerned there. So.
Yeah, and to add on to that, we had a case where we were planting early April, and we actually had the planter sitting for 30 days, and we can actually see the yield difference. When you're planting 12.5 mile an hour, granted, not everyone's going to plant 12.5 mile an hour, but the technology is allowing us to plant faster. You can wait for that optimum window instead of planting earlier, trying to get all your crop in the ground.
Yeah, Scott, I like your autonomous tractors. The sooner the better. But for farmers, life is full of compromises. We have to work with what we have today. We have the acreage, the high horsepower, the weight, and those of us that have livestock also have manure to handle. And I'm a big fan of no-till, but the phosphorus issues in the Great Lakes, which you're very aware of, I know, are another consideration. Where do we go to accomplish all of those compromises in today's world?
Well, one of the things I think is most important is when you have the opportunities to make new purchase decisions in some respects, and you're presented with options, how do you select that option that's best for your operation? Now, I realize people are going to be using used equipment. I realize used equipment will roll over as well. I guess the biggest thing is be aware of some of these factors, and when you're presented with those purchase options, make the best possible decisions that you can for your operation. And by the way, what's right for your operation may not be right for your neighbor's operation, and I want to recognize that too. This issue of phosphorus going into the Great Lakes is a bit problematic in that we know parts of what's causing it, but we don't know everything. One of the things that if we could do is if we get farmers to spread the fertilizer application out over the year, instead of putting it all on up front at spring, right before planting, I think it would change that dynamic in terms of what's going on in the lake substantially. We also have this issue where a lot of our no-till farmers are applying that fertilizer over the top that they always have, and we're also seeing some nutrient stratification. So some strategies to get it below the soil surface without disturbing the soil greatly. I think those sort of things are the sort of things we're going to be looking for to solve some of those problems. The solution is not going to occur overnight. The problem's not going to go away readily. And again, one of the things I remind people of is Lake Erie is a relatively shallow lake, and the problem's going to be more pronounced there than it will in the other Great Lakes just because it warms up so quickly. And you get the heat, you get the right nutrient balance in there, and that's when we have the harmful algal blooms. But yeah, I think agriculture is going to have to learn to do its part to help mitigate part of that problem. I think there's a lot of opportunities out there as well.
And I'd add, at least in the state of Ohio, there's at least discussion today that policy-wise that might drive what are implement. And so I think right now one of the top 3 BMPs or best management practices for phosphorus application is subsurface placement. Now that could be surface placement with a 12 to 24 hour turnaround on a disking or some kind of incorporation process. But for the no-till guys, they're kind of limited to a kind of a strip till unit, possibly with an injector. And that can do 2 things that we're starting to talk about. Number one is you can inject that phosphorus, get it subsurfacely, and that's meeting the BMPs and potentially the policy. But secondly, what Scott hadn't brought up is a preferential flow. And we've gotten a lot of new tile systems in, and what happens over those tiles when it dries, it cracks. And so you get preferential flow. In order to break that up, even in a no-till condition, you could use a strip till to help break up that soil kind of in the spring/fall, not only place, but deal with that preferential flow issue of phosphorus into that tile. So we have proven, Kevin King, and I think you're talking about having him next year on this, can talk very eloquently to that, is that we got phosphorus coming out of the tile as well. So we got to think about both the surface and subsurface movement of that.
And let's not forget about this overall issue of soil quality, soil health as well. And again, if we can do things to get that organic matter content up, to increase the infiltration rates, it's going to make a lot of these problems, it's going to minimize them to a certain extent. Right now, we have some rainfall events that are pretty substantial rainfall, or excuse me, runoff events. If we can get the infiltration rate up, that helps us quite a bit too in managing that nutrient issue.
Yeah.
So I'd like to direct over your attention to the screen. You'll see that there's a group of folks up at 3 tractors up in Burlington on our south end location of WebEx, and there's a question from one of the folks in that group. What axle load is our compact soil inches, all inches?
Oh, yeah.
You want to handle that, Andrew? Oh, Andrew's passed the question to me. I think our standard response to that is, with respect to deep compaction, if we know that our axle loads are under 10 tons, we really don't worry about it too much. Now, having said that, I think we can still be doing surface compaction, and part of that's going to be that contact pressure issue. And so, again, when we're talking about the shallow, the 0 to 6, a lot of that's going to be governed by contact pressure, okay? And what I go back to is it's the deep compaction that is really governed as much as anything by axle load. And so I think that helps us differentiate a little bit. We get up over 10 tons, I start to get concerned about what's going on down below the soil surface. And so the question is how can we manage that a little bit better? Obviously, if it's a dry soil, a 20 or 30 ton axle load, I'm not going to worry about that too much, okay? It's really when we get into the field capacity conditions or the plastic soil states, if you will, that the higher loads really concern me. And so, again, I'd use that as kind of that break point in some respect. Contact pressure when it's on top, and then be careful when you're getting up above the 20-ton axle loads when you're looking at wetter soils, certainly.
The question was on depth, though, correct?
Yeah.
How deep? So we always say 0 to 12 is that contact pressure. 12 to 20 is both contact pressure as well as your axle load, and 20 inches and below is all axle load. So that's sort of how we break it out. in looking at the three regions. We have the topsoil and then the upper part of that subsoil and then the subsoil below.
Okay, I think questions for John, point pressure in tillage equipment. I'm just envisioning a tillage tool such as Vaderstad with a packer roller at the back, which just on its own would be running 10 PSI. And then in front of that, a tillage tool with independent discs. So if the tillage aspect was running at whatever depth, say 1 inch, and the weight is being carried by the roller, does that minimize the point pressure versus traditional disc harrow, for example? It's a point pressure question.
If I understand the setup, that if you're transferring the weight over in the roller, that would help.
Correct. The weight is being carried by the roller.
Point load on the disc itself.
Right. So basically the discs are just running at that tillage depth.
Right.
Does that address that
Yeah.
point pressure then?
Yeah.
Yeah.
Yeah, you're transferring that off. That's going to reduce your PSI, your point load on that, each and every disc. Yeah.
Many years ago, when I was in ag school, the teacher already knew the answer to how fast we will drive our tractors. And that is so long we can maintain behind the steering wheel. But the question is, does speed affect compaction? And then the other thing we talk a little bit about, and maybe you can, since you guys are the tire experts, we have now the capability of moving 15,000 gallons of manure behind the tractor on the radial tires, which tend to roll because of the soft side wheel. And we are able to move that at 50 kilometers an hour. And we have the, I think, the legal ability to have a 16-year-old sitting behind the steering wheel. This could have the potential for a big bang. And I'm wondering whether you could give us any guidance, what type of tires and what kind of weight loads you can safely move at those speeds along the road, because today we can move 50, but tomorrow we can go 60 or 70 with that weight, with that 16-year-old.
Well,
I'm worried about it and hope it never happens.
I'm going to start out, and I'm going to take you in a bit of a different direction in some respects. When we see high towed loads, okay, it's the number one safety thing is about being able to stop that load, okay? And so what it really argues for is, do we have adequate braking? And the tractors designed today are not necessarily designed to handle the braking loads for that big of towed load in some respects. And so it really argues for braking on the manure tankers. And so the first question I'd ask is, in terms of road safety, is do we have adequate braking to stop that piece of equipment at the higher road speeds? And I think that becomes one of the critical things. You also talk, and I think you were headed towards the stability. And we know some of the long trains of agricultural equipment, especially with product carts or slurry tanks, you know, most of the tractors were not designed or ever envisioned to go 50 kilometers per hour, although I know increasingly that's important. I know that's been an important issue in Europe. We also see suspension on tractors in Europe. It's something beginning to be adopted in the U.S., but obviously there's a cost there. And so this whole tire issue in some respects, really when we think about tires, we want inflation pressure systems so we can minimize the tire pressure in the field because of that compaction issue. But then when we get it out on the highway, we want to make certain that we can pump those tires up in some respects. And so those could be potential solutions. The issue of the 16-year-old, man, for a while in the U.S., they were going to require people operating farm equipment to have CDLs if they went across state lines in some respects because of the commerce interstate laws. And I don't know that a CDL really guarantees the driver has the experience. What I'm concerned about more about than the age of the person sitting in the seat is the kind of training that individual had or the kind of experience that individual's had. And what I'm saying is we can put some 24-year-olds behind the steering wheel of that tractor, and the people on the public thoroughfares can be in every bit as much danger just because they haven't had the experience with that equipment. So I think it's really an educational aspect in some respects. You know, we shouldn't be putting 14-year-olds in there. I'll be the first person to agree there. But again, I want to know what kind of training and experience the drivers have in some respects.
I know we're running short on time, but one of your comments earlier, you just, and this could be a whole nother presentation, but infield speeds, we talk about high-speed planning, we're talking about some of these other field operations of increasing field speeds. What I will tell you is you've got weight transfer going on there, and some of the ballasting and getting that weight back transferred like on the planters becomes very important. My point is, when we start doing 10-mile-an-hour planning or greater or such, is there's some weight transfer going on. So what I tell you goes on at 5 miles an hour is a little different than what goes on at 10 miles an hour.
Yeah, and the other thing is we'll amend that field speed in terms of planting. I think you're right. If you can sit in the seats, pretty good indication. But we also look at the row units, and if we have rocks in that field or we have much of an undulating terrain, much in the way of elevation difference, we're not going to be planting at 12 and a half or 13 miles an hour. There's no question about that. Okay.
One more.
No, we're going to quarter after.
Open her up.
You said that soil fails in shear, and then you said that tractive efficiency was greatest at, say, 10 to 20%. So is there, to me, when you say tractive efficiency and 20%, that's 20% slip, 10 to 20% slip. So is there a correlation there between, compaction and tractive efficiency, like in that 10 to 20% range?
Well, I'm going to go back and address the 20% slip and why that's important. If you notice that one curve that I showed, at 100% slip, we get the greatest pull, okay? But we know that horsepower transfer to the ground is a combination of travel speed and the overall force, okay? So when we multiply those two together, the travel speed and the overall force, which is power, okay, we find that the maximum power transferred is at that 20% slip. We need some slip because we know that soil fails in shear. Now, the other question that you asked, I think, is about higher speed operations and what influence that might have on compaction.
No, not really. It's just, you're talking about that as you reach that, because when I'm in the field, I don't like to see much more than a 10% slip on my machine.
Yes.
So what I'm trying to ask is really, does the compaction increase as I reach that 20%, or is it really just related strictly to axle load?
The compaction at most of the field speeds we're talking about is going to be directly a result of the contact pressures as well as the axle loads, okay? And so I don't know that slip one way or another, unless of course you start moving a lot of soil, could be problematic, but slip in general is not going to affect compaction, at least within the range, the operating ranges that are typical for agriculture.
Thank you.
Okay.
With respects to corn planting, you see different outfits and different row configurations. Have you guys done any work with, let's say, like a row crop tire staying away from the row, or some guys go for flotation tires like 800s and spread it out?
Andrew, you want to do that?
Yeah. So we have started, just this past year, we started looking at pinch row compaction, and we put Sushi tracks on a John Deere 1775 planter, and we ran that with just duals on the tractor. And we also have where our track tractor, we have half tracks or Magnum road tracks where they're on 120-inch centers, so that's putting everything in the same trafficked area. So this year, and what we saw was about a 10 to 20 bushel yield loss compared to regular tracks or wheels, pinch rows. And this year, that question keeps coming up, and we're going to start looking at a 4-track system. We have not starting to look at those IF tires, but if we can start making relationships in the grain carts where you have an IF tire and a grain cart or tracks, we can start looking at the relationships, but we have not started that yet.
Well, and the other thing I'll add is what you're talking about in some respects is whether or not we're going to traffic the area that gets planted when we go to wider tracks. We're going to see a lot of evidence of that coming because some of the bigger planters in some respects, if you go to high horsepower tractors on tracks, pretty quickly the 18-inch track doesn't meet your needs anymore. We are talking about what it may look like on one planter using a quad track that I think was a 24 or 32-inch track on the quad track. 24. So we're going to have some of that evidence, but you're exactly right. We're going to be doing some surface compaction before we plant, or the row unit goes through there. What it might argue for is higher downforce settings on those row units that are behind that traffic region to end up with similar plant stands or whatever. So We have the ability to do that now. 10 years ago, we wouldn't have even been thinking about it necessarily. So I think the IF tires could fall into that category as well. In other words, moving away from row crop, at least in planting, and using bigger tires, bigger tracks in some respects. But we'll definitely be looking at some of that in terms of what we're planning this next year.
Yeah, our 4-track tractor had 18-inch belts on it this year. And I got to a point I was in some fields, it was so wet, even with tracks, I did not back into a corner of a field. So this year, I was staying in a travel row where I was on 120-inch centers. This year, the reason we're going to 24 inches is I just want more flotation. I'd rather run over a row than leave ruts out in the field.
Have you considered looking at cover crops as both an alleviation of compaction as well as reducing? Or I should say reducing and then alleviating.
John, you want to take that one?
Yeah, we've got I guess I'm going to speak for a group of people in Ohio. We got a no-till group that's and they've been doing multiple years of cover crop research. And as I mentioned, there's two things that they're trying to accomplish with that. Number one is mitigating compaction, improving soil health, but really trying to build organic matter. And secondly, what they're trying to do with these 6 species type mixtures that they're doing is trying to retain that residual nutrient carryover, especially nitrogen in some cases. And so I think going back to Randall Reeder's been mentioned multiple times today. I have to go back and exactly look, but I mean, they've seen a reduction in soil penetration resistance based on some of that work using cover crops to try and mitigate compaction, especially in no-till conditions.
And also just having the cover crop in the crop that you're harvesting, there's some evidence there that it could reduce it right from the outset, like say with the combine operation.
I don't have any data on that, but I know Les and talking to Brian that you're right. If you can get the cover crop established, let's say August, a lot of times it seems like our guys are talking about trying to get that established out there in that growing corn crop. When you get to harvest, the potential for rutting, keeping kind of more of that flotation. And Andrew, there's evidence that having that growing crop helps deal with that versus not having that and having a very rutting, mudding kind of condition.
Right. Yeah, there's evidence. It would be nice to see some actual research done on that.
Yeah.
Sorry, just want to cut in here for a second. See, not to get it on the folks in Thunder Bay, send them a shot of their group that are participating. They don't have any questions.
Good afternoon, Thunder Bay. Okay,
Max?
I just wanted to go back 2 questions. The question about driving on the planted row by the tractor and offer a personal observation from a couple years ago. My planting tractor is about 185 PTO, pulling an 8-row corn planter, and I had 900 singles on the back at 5 PSI. And I was impacting the planting row where the moisture was high. So I go back to the work by Sony where he talked about the moisture affects the compaction most of all. And that's the comment I would like to make to the gentleman who brought that question forward, is that when I got off of the drier or onto drier soils, waited a day or 2 or 3, the impact was not there anymore. Since that time, I've gone back to the planting of corn to stay off the row. I'm using 18-4 duals and staying off the row for corn. For beans and wheat, doesn't seem to make the difference. Maybe the moisture is lower almost uniformly at that time, but that was my observation then. And that comes back to the very first question that was started, which was mine. I actually got to a point with those tires where at 5 PSI, I'm losing traction. And my old planting tractor on 20.8 duals, I can pull that new tractor backwards anytime I want, because I think the question is I can't set the lug. And when you talk about soil failing in shear, I think it matters how much lug you've got in the ground and whether you're grabbing the dirt or just slipping on the surface.
Just a sidebar comment on that, because that's a very good point. Generally, most of the studies that have been done with lug height on tires, under good tractive conditions, you can take the lug off the tire, it doesn't make any difference, okay? A lot of people, generally, the biggest reason for lugs on tires is really twofold, being able to road the equipment, and the other thing is what happens under too wet of conditions or muddy conditions, okay? Generally, if it's good tractive conditions, the lug has little effect on the tractive effort. It's one of those things that is not well known, but has been well documented by a lot of the engineers. So worn tires, you're not quite as concerned about unless, of course, you get into muddy conditions and things like that.
With grain buggies, then there are multiple axle buggies, but then there's the ones that have the like a walking tandem. Does that is that two axles or is it just a bit of a compromise? And then with a tracked grain buggy, how many axles does that have? Like is that really helping that deep compaction if 10 or 20 ton an axle is important?
Yeah, I'll take the walking beam question first. I would consider it to be a multi-axle grain cart. And one of the things I like about the walking beam is what you're trying to do is make certain that both tires have a uniform load on them in some respects. And so, yeah, a walking beam I consider very much a multi-axle grain cart. When you got to be careful though, you want the tires to be in line, not necessarily side by side. Okay, and there are some grain carts where you have side by side tires that they'll move independently. The other comment was about
How many is it? Tracks, one axle?
tracks one axle. Generally what happens with the track, if you want to think about it in terms of equating the track to wheels or tires, you got the front and rear idlers, and then you have all the idlers in between. So as much as anything, you can kind of think of it as multiple wheels if you want to think out of it. What you're doing is you're spreading the load out lengthwise across the machine in the direction you're traveling, which is a very good thing to do to reduce soil compaction. So the tracks, by virtue of the fact they're longer, would be advantageous in helping reduce the deep compaction for high axle loads. Yes.
The only caveat I would add to that is that our newer track systems are much better of getting that load distributed between the main idlers and those bogey wheels. You go back 10, 15 years, some of the tracks, those bogey wheels weren't carrying much load as was perceived. And so you ended up getting the main drive or on the tractor or the idler carrying most of the load. So you're getting yourself back to more of a point load in that case, or a reduced footprint. But today, when you look at the tracks coming on combines or available on combines, the tracks that Andrew suggested on grain carts, they have done a much more improved technology to get that load distributed amongst all the idlers and bogey wheels today that was not present back several, 10, 15 years ago.
In general, if you can distribute the load with the direction of travel, it's a much better condition than doing it widthwise.
Do I have a minute left? I have two questions. Well, first of all, then I'll ask, have you ever seen any compaction or decompaction associated with tile installation with these plows? And I don't even know how much they weigh, but I'm sure a lot of them have older idler configurations, and a lot of times they're tiling under conditions that aren't ideal. Have you ever seen any deep compaction associated with installing tile?
Yeah, so our family farm owns a tile plow, and we've had one of the first ones, and it's a pull type, not a 3-point mounted. And I would say we see very minimal effects. Now, we're probably one of the exceptions. We go in, we tile a lot in July. This year, we actually tiled some in December, so it wasn't such favorable conditions. But most of the time, you're loosening the soil profile, and the plow does not weigh as much as you think it initially does. So there's different versions of it, whether it's carrying the roll or not carrying the roll. And we have not seen that effect on our farm. And we are in extreme heavy clay soils. So I guess that's the answer I have.
As long as you're not getting a lot of inversion.
Yeah.
Well, I've seen a lot of inversion happening, and you get the subsoil basically inverting the topsoil and subsoil. I've seen some influences of that are long lasting.
Yeah. I will say when you start getting up in let's say you're pulling a 6-inch outlet or your bigger tile, you can either pre-rip at one depth and go back. But if you're trying to do it in one shot, you're going to have a lot of slip, and we've seen damage that way where if you just hook up 2 tractors, we've done that, or actually going back to a wheeled in.
You gotta keep being on schedule.
Okay.